folks, in this video I would like to talk about addition and subtraction of rational expressions. And what we've done before is we've simplified rational expressions, we've multiplied and divided rational expressions, and now we want to add and subtract. And add and subtract, there's a little more involved than multiply and divide. Remember, when you simplify, you want to factor everything possible, write everything as multiplication and cancel common factors. When you multiply and divide, you want to factor everything and cancel common factors. The extra thing about division is you have to remember keep, change, flip. Now we're dealing with addition and subtraction. And if you'll recall, when you add and subtract fractions, you must have a common denominator. So for example, if I just squeeze a problem up here, 1/2 plus 3/2 is perfectly okay to add together. 1/2 plus 3/2 is 4/2, and then I reduce that to lowest terms, and that's 2. On the other hand, 1/3 plus 3/2 is not so simple to add together because our common denominators must match. Yeah, might as well finish that problem out, right? Our common denominator on this problem would be 6. And to handle this, to make this a 6, I need to multiply this fraction by 2/2. And I need to multiply this fraction by 3/3. And then that would give us 2/6 plus 9/6, which would be, add the numerators, 11/6. And our rule over here basically says that if we have a common denominator, notice the C and the C, then we just add the numerator A plus B together. Sometimes these are like terms, and sometimes they're not. It just depends on your problem. So let's do a few problems that have common denominators, and then we'll address what we need to do if we don't have a common denominator. So our first problem here, 5x over 3 plus 8x over 3. So again, the first thing I want you to think about when you see fractions adding or subtracting is, do I have a common denominator? Yes, I do. I have a 3. So I could rewrite this as 5x plus 8x over that common 3. But fact is, I can add 5x and 8x together to get 13x over 3. And then I would be required to reduce this fraction to lowest terms, but 13 and 3 don't cancel. So that problem is complete. And when I look at the second question, once again, I'm adding fractions. Do I have a common denominator? That should always be your question. And I do. I have an x. So I have 7y plus 3 over our common denominator x. And then if I could combine 7y and 3 together, I would, like I did the 5x and the 8x. But 7y and 3 are not like terms. So I'm completely finished with this problem. Notice there is nothing that will factor and cancel, so we are finished with this page. So for example C, I have, again, I'm subtracting, so notice the big minus in the middle. I have a common denominator. They both have an x minus 2. So what I do is I write my one single fraction bar with my common denominator underneath, x minus 2. And in the numerator, I have 2x minus 3 minus x minus 1, except what I wrote is an error, okay? I'm minusing this entire x minus 1, so I must put parentheses. So please don't forget about those parentheses. This subtraction has to distribute inside, and that's going to be my next step. So I have 2x minus 3 minus x plus 1. So again, I'm multiplying that negative inside the parentheses over x minus 2. And now I have like terms. I have a 2x and a minus x I can combine together to get x, and a negative 3 and a plus 1 that I can combine together to get a minus 2. That's divided by x minus 2. And look, I have common factor on top and bottom. I can cancel this x minus 2 with this x minus 2. And overall, this answer is 1. Do remember, when you cancel your common factors, that's really a division step. So when you divide the top by the same factor in the bottom, that's going to give you a 1. Just like 2 divided by 2 is 1. All right. And I'm checking that again just to make sure I didn't make an error. Yes, that's correct. Okay. So let's look at another problem. I have, look at this. I'm adding and subtracting. But look at our denominators. I got an x squared plus x minus 2, another x squared plus x minus 2, and another x squared plus x minus 2. Now, this is still a big problem, though. I'm going to write all this as one fraction over our common denominator of x squared plus x minus 2. Then I'm going to write down what I have in the numerator. That's 4x squared minus 33x. Now, when I add, I don't have to worry about the signs changing. I can just recopy the next one. But now when I subtract, that's when I have to put the parentheses. But notice there's already parentheses over here. 3x minus 2 times x minus 7. So now we're left with how in the world are we going to simplify this? Well, here's what we got to do, folks. This 3x minus 2 times x minus 7, I have to FOIL that out and then distribute that minus sign inside. Over here, I have some like terms I could go ahead and combine together just to make it look a little bit better, but I still have a lot of work to do to get this problem finished. So I've got 4x squared. Y'all bear with me while I pick my color better. There we go. So I've got 4 and my size. Hold on. I don't like that. Okay. Something went wrong. Alright, so I've got 4x squared, and then a negative 33x added to a positive 2x is a negative 31x, and then minus 6 minus, now watch this, I've got to do 3x times x, that's 3x squared. 3x times negative 7 is negative 21x. Also got to do negative 2 times x is negative 2x, and negative 2 times negative 7 is plus 14. That's all over my common denominator of x squared plus x minus 2. Now, why did I put those brackets around there? Because I'm subtracting all of that. So this negative must distribute inside. So let's keep going and simplifying. I'm probably going to have to go on another page to keep going. 4x squared minus 31x minus 6. Now, this minus times this 3x squared is going to be minus 3x squared. Now, look right here. I've got like terms. Minus 21x and a minus 2x is a minus 23x. But when I multiply the negative times that, it's going to be a plus 23x. Did you catch that? So again, I've got some like terms right here to give me negative 23x, but when I multiply that times that negative, it's plus 23x. And then the negative times the positive 14 is negative 14 divided by x squared plus x minus 2. Now, let's check out like terms here. 4x squared, I can combine that with a negative 3x squared. I got like terms. That's 1x squared. I'm just going to write it as x squared. A negative 31x and a positive 23x. Remember, I subtract those, keep the sign of the heavier one, which is negative. 31 subtract 23 is going to give me 7x. How about 8x? Alright, and then a negative 6 and a negative 14 is minus 20 over x squared plus x minus 2. And now we're charged with the fact that we need to factor and cancel if at all possible. So my numerator, I'm looking for numbers that multiply to be negative 20 and add to be negative 8. And that will factor because that's going to be a negative 10 and a positive 2, right? So that's x minus 10 times x plus 2. In the denominator, I'm looking for numbers that multiply to be negative 2 and add to be 1. That's an x plus 2 and an x minus 1. Notice I've got common factors of x plus 2. So my final answer, I'm right at the very top of the page, is x minus 10 divided by x minus 1. And that cannot be simplified further. So even when they have a common denominator, sometimes you have a great deal of work to do like this. And really, honestly, what made this probably the biggest problem is the fact that that wasn't multiplied out. We could have even done that right at the beginning before we added and subtracted all three of our fractions. So we looked at several problems, about 4 different problems where we had a common denominator already. So the question is, what if the denominators do not match? Okay, so factor each denominator completely. You must factor everything completely. The least common denominator consists of the product of each distinct factor, the maximum number of time it appears in any one denominator. I know this sounds overwhelming. We'll take a look at that, don't worry. You build the new fractions so they have the same common denominator. You multiply the numerators. You perform the operation. So those are the steps. You will do this every single time. But now these first couple of problems, we're not going to do all those steps. All I want to do is find the common denominator here. Now notice our three different fractions. These are all factored already. And all factored means is multiplied together. A factor is something being multiplied times something else. So 14 is a factor, x to the third is a factor, 21 is a factor, x squared, y to the fourth. You get it, okay? Now first, let's look at just 14, 21, and 12. So I have got to find a common denominator for 14, 21, and 12. Now there's a way to handle this. I can break 14 down into 2 times 7. Those are the prime factors. So 14 breaks down into 2 times 7, and then we can pull over the x to the third that's up here. 21 breaks down into 3 times 7, and I can bring the variables down too. So that's going to be 3 times 7 times x squared times y to the fourth. Okay. 12 breaks down into 4 times 3, but 4 will break down again into 2 times 2. So 12 is 2 times 2 times 3, and then times x to the fourth times y to the third. Okay, now here's where it gets fun. Notice this says the least common denominator consists of the product of each distinct factor, the maximum number of times it appears in any one denominator. So notice a 2 shows up. I'm just looking over to the far left. 2 shows up. 2 shows up once here, none here, and twice here. So the maximum number of times it shows up is twice. So I need 2 2's, or 2 squared if you like. Look at 3. 3 shows up none, once, so I need 3. It just shows up one time. It's the most number of times it shows up. 7 shows up once, none, so we need a 7, just one time. Now let's look at the x's the same way. I have an x to the third, an x squared, and an x to the fourth. I need the most number of times it showed up, which is x to the fourth. Let's look at the y's. None at all, y to the fourth, y to the third. The most number of times it shows up is y to the fourth times. If I multiply that out, by the way, all this is calculation area. If I multiply that out, it's going to give me 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is going to be what? How about 84? So it's going to be 84 x to the fourth, y to the fourth. That is my least common denominator. So let's recap how I'm doing this. I'm looking at these as separate factors. Okay. So look, there's a 2. There's no 2 at all. There's 2 2's. So I need the 2 2's. Okay. And then I'll look up no 3 at all. There's 1 3. There's 1 3. So I need 1 3. There's a 7. There's a 7. There's no 7 at all. So I definitely need a 7. Now I could have highlighted this one or this one. Doesn't matter. I've got x to the third, an x squared, and x to the fourth. You need the most number of times it shows up. No y, a y to the fourth, a y to the third. I need the most number of times it shows up. The highlighted ones are the ones I have down here. So 2 times 2 times 3 times 7 times x to the fourth times y to the fourth. And that gives me 84x to the fourth, y to the fourth. Alright, so let's try this again. But this is different because these are all factors. These are not factored. So x squared minus 9, I factor that to x plus 3 times x minus 3, whereas x squared plus 6x plus 9 is x plus 3 times x plus 3. Now, you can think about this as x plus 3 squared if you like as well, because there's 2 of them. You can't write that as squared because it's 2 different factors. Now, I need every factor that shows up the most number of times it shows up. So an x plus 3 shows up once here, but it shows up twice over here. So I need it twice. And an x minus 3 shows up once here and none here, so I need it once. And this is your least common denominator. Now we'll get to practice that many, many more times when we're trying to find a least common denominator so we can add our fractions together. So I see that I'm subtracting two fractions. The first thing I have to ask myself is, do I have a common denominator? And look, no, I don't. So the first thing I have to do is find a least common denominator. This is already completely factored. 5 won't break down anymore. It's prime, neither will 3. So I have to use everything that shows up the most number of times it shows up. So a 5 shows up once here and none here, so I need a 5. Okay, a 3 shows up once here and none here, so I need a 3. An x squared and an x, so I need the most number of times, which is x squared. A y and a y squared, so I need the most number of times, which is y squared. So if I simplify that, that's 15x squared y squared. Okay, now what we have to do is we have to take our problem, I'm going to write it a little bigger, and build our common denominator. So I'm going to do this in a different color so you can see it. So to turn a 5 into a 15, I need to multiply by 3. An x squared into an x squared, we're already there. But a y to a y squared, I need to multiply by y. So if I multiply 5x squared y times 3y, it'll turn it into 15x squared y squared. But I can't just multiply it on the bottom, I also have to multiply it on the top. So now my fraction is going to be 3 times 3 is 9y over 5 times 3 is 15x squared y squared. Okay? Now I'm going to do the same thing here. I'm going to build this fraction so I have a 15x squared y squared on the bottom. So to do that, to turn a 3 into a 15, I have to multiply by 5. To turn an x into an x squared, I have to multiply by x. And to turn a y squared into a y squared, I don't multiply by anything. So I need a 5x on the bottom, which means I need to multiply the numerator by 5x as well. So now our problem turns into 2 times 5x, that'll be minus 10x over, again, 15x squared y squared. And now this looks like the problems we did on the first couple of pages. I have a common denominator. I can write it underneath one fraction or in the denominator, and then 9y minus 10x. If these were like terms, I combine them together, but they're not. And there's no greatest common factor I can factor out, so I can't simplify this at all. That is our final answer. So let's try this again, dealing with 4b squared and 25a squared. So my least common denominator, I'm going to do this on the top right here, a 4 and a 25, better fact, 25 factors into 5 times 5, if you need that. 4 breaks down into 2 times 2, but notice they don't have any common factors. So, I mean, I'm going to need 2 2s and 2 5s, or 4 times 5. I'm going to need a b squared, and I'm going to need an a squared. This had no common factors at all, so my least common denominator is 2 times 2 times 5 times 5, which by the way is 100, and b squared, a squared. Feels better to me to write a squared first, so I'm going to write it as a squared, b squared. Remember, the order you multiply in doesn't matter. Alright, now I've got to build my fractions, so I'm going to rewrite my problem with some space. 5a over 4b squared minus 16b over 25a squared. Now I'm asking myself, what do I need to multiply 4 by and b squared by to make it 100a squared b squared? Well, 4 times 25 gives me 100, and then to get the a squared, I need to multiply by a squared. So I need to do this both in the numerator and the denominator. And that's going to give me, in the numerator, 5 times 25 is 125, and then that's going to be a to the third. and that is over my common denominator of 4 times 25 is 100, a squared, b squared. Now I'm going to work on my second fraction over here. I need to multiply 25a squared by something to turn it into 100 a squared b squared. Well, 25 times 4 will give me the 100, and to get the b squared, I need a b squared. And I must do this in the numerator as well. So we do 16 times 4 is going to give me 64. And b times b squared is b to the third divided by 100 a squared b squared. Now, I combine like terms. No, I don't. Not yet. How about we just write this in as one fraction, okay? And then 125 a to the third minus 64 b to the third over my common denominator of 100 a squared b squared. Now, this numerator up here is a difference of cubes. If you notice that and say, hey, I know that'll factor, it will. But the fact is, it's not going to cancel with one of these factors in the denominator, because that factors into a binomial, which is 2 terms, times a trinomial, which is 3 terms. And these are all that's just a monomial. You're not going to have like a 5a minus 4b that you can cancel with. So this is as good as this gets. Again, you could factor the numerator, but nothing will cancel. So either answer is acceptable, and I'm just not going to factor it. All right, let's continue with 3 over x plus x over x plus 2. Now, look, we're dealing with some addition here. And I can't just add 2 to this x. The only way to build a common denominator is to multiply. So x is a factor and x plus 2 is a factor. And our least common denominator is just that, x times x plus 2. So when I rewrite my problem with a little bit of space, 3 over x plus x over x plus 2, now I want to build my common denominator by multiplying by what I'm missing. If this is my least common denominator, this one's missing an x plus 2. So I need to multiply that both in the numerator and denominator. X plus 2 over here is missing an x, so I need to multiply that in my numerator and denominator. Here I distribute, so that's going to be 3x plus 6 plus x squared over x times x plus 2. Now, you do not have to distribute, you do not have to distribute denominators. You can leave those factored. But this 3 times x plus 2, you must distribute the 3 inside. Now, in the numerator here, I need to add like terms, but I don't have any. So I'm just going to rewrite this as x squared plus 3x plus 6 divided by x times x plus 2. Now my next step would be to factor the numerator if possible. The denominator is already factored. But there are no numbers that multiply to be 6 and add to be the middle term 3. So this is completely simplified. Then we move on to our next problem. X plus 7 and x minus 3, they also don't have any common factors. X plus 7 is a single factor. It's not like x and 7 are separate factors. When you're adding, that's a single factor. X minus 3 is a single factor. So when I rewrite my problem, so I have a little bit more space here so we can build our common denominator. Our least common denominator is just those two multiplied together, x plus 7 times x minus 3. So I'm going to multiply by what I'm missing. The x plus 7 is missing an x minus 3. I'm going to multiply that in both the numerator and denominator. And on the other hand, my x minus 3 is missing an x plus 7. And I'm going to multiply that in the numerator and denominator. And I'm going to write this as one big fraction with my common denominator to remain factored in the denominator. In my numerator, I have to simplify. I distribute, that's 5 inside, so 5x minus 15. Right here, now if you want, you can take that negative with the 2 and distribute the negative 2 inside. So that'll make that negative 2x minus 14. So did you catch that? So I took the negative with the 2. Negative 2 times x is negative 2x, and negative 2 times positive 7 is negative 14. Now we add like terms. 5x added to negative 2x is 3x, and negative 15 plus a negative 14 is negative 29, divided by x plus 7 times x minus 3. If we could, we'd factor our greatest common factor out of the numerator. Nothing will factor there, so that problem is completely simplified.